All right, section 4, scheduled for today. And we're going to work on exponents today. So let's talk about the laws of exponents first before we get started. Then we'll go down through some problems here. Law of exponents. There are 3 primary laws of exponents. When you have, well, that one's evidently no good. Pardon me. Try this one. There are 3 primary laws of exponents. When you have, for instance, x squared times x cubed, you have 2 x's here multiplied times 3 x's. So how many total x's are you multiplying? You're multiplying 5, which means you add the powers. Now the bases have to be the same. If it's x squared and y cubed, can't do anything with it. It stays x squared y cubed. But you have 2 x's and 3 x's. That's a total of 5 x's being multiplied. Okay? Second one. How about if you have x squared, then raise that to the 3rd power. Okay? Now this means x squared times x squared times x squared. Isn't that what an exponent means? It tells you how many times to multiply. X squared times x squared times x squared. How many x's are you multiplying? 2 x's times 2 x's times 2 x's. That is to the 6th. Okay? So a power raised to a power, you multiply the powers. Okay? What about if you have a quantity like xy squared? Okay? You take xy times xy. Xy times xy, there's 2 x's and 2 y's. So it is x squared, y squared. It's kind of like a distributive property. You can take the 2 into both parts. Now, I want to be real cautious here. You can only take this power in if it's multiplication or division. All right? If it's addition, forget it. For instance, check this. 2 times 3 squared. We know that 2 times 3 is 6. 6 squared is 36. Yeah? Can I take the power in? Sure. 2 squared, 4. 3 squared, 9. 4 times 9 is 36. So it works. Okay? But what if it's not a division or multiplication? What if it is 2 plus 3 squared? Can you take the power in? Well, let's check it. 2 plus 3 is 5. 5 squared is 25. We know the answer is 25. If you take the 2 in, you're going to get 2 squared is 4. 3 squared is 9. 4 plus 9 is 25. I don't think so. Okay, so it only works here, rule 3, if it is multiplication or division. All right? Now, we want to talk about 0 powers and negative powers. Okay? So let's talk about it. Let's start with 3 cubed, 3 squared, 3 to the 1st. Everybody see that okay? No, I'm worried about my markers. Yeah, it looks pretty good so far. All right, 3 times 3 times 3 is 27. 3 squared is 9. 3 to the 1st is 3. You see on the left-hand side, we're dropping the power by 1. Okay, I'm simply dropping the power by 1. On the right-hand side, I'm dividing 27 by 3 to get 9. I'm dividing 9 by 3 to get 3. So I'm dividing by 3 over here. All right, so let's drop the power by 1 and get 3 to the 0. Okay, divide by 3 over here, and you get 1. Now, I could have started with 7, 22, 43. I could have started with any number. I didn't have to start with 3. I just started with 3 because it was a nice, easy number to work with. Okay? No matter what you start with, this is except for 0. No matter what you start with, the number to the 0 power is going to be 1. Okay? So that is the kind of the 4th rule of exponents. If you raise a number to the 0 power, you get 1. As weird as that is, you get 1. Now, let's do it again. Drop your power again. 3 to the minus 1. Divide by 3. 1 divided by 3. A whole pizza cut in thirds is 1/3. Okay? Right? Divide by 3, you get 1/3. Do it again. Drop your power, 3 to the minus 2. Divide 1/3 of a pizza by 3, and you're going to get 1/9 of the pizza. All right? Now, the cool thing about this, do you see how 3 to the first is 3, 3 to the negative 1 is 1/3. 3 to the second is 9, 3 to the negative second is 1/9. Okay? So a number to a negative power is the same as the number to the positive power, except it's flipped. Negative powers flip. Okay? 0 power is 1, negative powers flip. That's the way you've got to remember that. All right, now with those basic rules of exponents, let's see if we can do these problems. Here's a problem like rule 1. If you have 4x's times 6x's, you have a total of 10x's being multiplied. X to the 10. That is like rule 3. You can take the 5 into both parts and get x to the 5th, y to the 5th. All right? How about dividing? We didn't really talk too much about that. If you have 5x's on top of 3x's, can't you cancel? Like reducing fractions? Can't I kill 3x's here totally and kill 3x's on the top? How many are left? Isn't it x squared on the top? So this answer is just x squared. But this one, if you cancel 3x's on the top with 3 on the bottom, you're left with 2x's, but aren't they on the bottom? Okay, 1 over x squared. Did I need the x squared over 1 here? Do I need the 1 on the bottom? No, but you do need the 1 there. Here, 2/3 squared, we talked about that in this one. When it's multiplication or division, you can take the 2 in. So 2 squared on the top is 4. 3 squared on the bottom is 9. Now, this is a negative 2. It's exactly the same answer, but it's flipped because it's a negative power. So this should be 9 over 4. Negative exponents don't make your answer negative. Negative exponents flip it. Okay? Negative exponents flip it. All right. Let's go on down here to some more. Okay. All right, here's a lot, just like rule 1. When you're multiplying, these are all x's, you can simply add your powers. 5 and 3 is 8. 8 and negative 2, you subtract and give it the sign the biggest. That should be x to the 6th. Yeah. Here is, now this one you're going to have to be careful with. Let's write it. It's 3x to the minus 2, 6x squared. I would flip this one right away, and negative exponents flip. This thing should be x squared, but it should be on the bottom. So I'm going to get rid of it on the top. And if I move an x squared down here where I already have an x squared, it's going to become x to the 4th. Are you with me? Okay. Now you can reduce 3 over 6, and you still have an x to the 4th on the bottom. Negative 3 to the negative 3rd power. Let's take negative 3 times negative 3 is 9, times negative 3 is negative 27. You know you have 3 negative signs here. Negative 27. But because that power is negative, it flips. So it should be 1 over negative 27. Here is just plain old 3 to the negative 3rd. 3 times 3 times 3 is 27. Flip it. 1 over 27. Yeah? Oh boy. Here we got a good one. Okay? So, 2 over 4 you can reduce to a half. Yes? Now, none of the x's flip. They're both positive powers. So you can kill 3 x's out of 4, and aren't you left with 1 x? But where is it? Is it on the top or the bottom? It should be still on the top. These are both negative powers. They need to flip. They need to flip. The y to the minus 1 flips to the top and becomes a 1. The y to the minus 2 flips to the bottom and becomes a 2. Now you can kill the y on the top, kill that y, and it knocks one of them off on the bottom. So your final answer is x over 2y. And the hardest one of all is right here. Let's talk about it. We have 4xy, and this y to the minus 5, I'm going to move down to the bottom and make it y to the 5th, right? This whole thing here is a negative 2 power. The whole thing here is a negative 2. Negative powers flip. I'm going to take that whole thing up, and it becomes x squared y squared. You catch that? It's to a negative 2, so I'm going to flip it, and it becomes just a plain 2. All right? So what do I have on the top? I have a 4. When you square, take your power in. This is rule 3. Or sorry, this is rule 2. A power to a power. Power to a power, that should be x to the 4th here. And I already have an x, so that's x to the 5th. Let's do it again. X squared squared. Power to a power, you multiply. That's x to the 4th times an x is x to the 5th. This becomes y squared. And then already times a y is y cubed. So I've taken care of that. Now, can't you kill 3 y's out of 5? Kill those guys, and doesn't that mark it down to a 2? So your final answer is 4x to the 5th over y squared. That was a tough one. Okay. So let's go down to the bottom. This down at the bottom is a little bit more of some of the kind of problems we worked on a day or so ago. These are collecting terms on polynomials, okay? So very, very much like problems we worked, you can only collect if everything's the same, okay? Like here, everything's x squareds, yeah? So I can collect them. Now notice here's 2 negatives, and you should remember what to do there. Make them both positive. So 2 and 3 is 5, plus another 5 would be 10x squared. See how the x squared stays x squared? Okay. It would only change. What if this was 3x squared times 2x squared? If it was 3x squared times 3 times 2 is 6, and x squared times x squared would be x to the 4th. But because you're adding 3 cookies plus 2 cookies makes 5 cookies. They stay cookies. So we got a total of 10x squared. Now over here, you got to be careful. I have y squareds, y cubes, and y's. All right? So let's go in descending order. Put the biggest one first, biggest exponent first. Negative 6y cubed. Then we have a negative 4y squared. Then we have 3y plus 7y is 10y. Okay? Everybody still see that? I have a feeling this marker is dying also. All right. How about this one? This one I have to take the negative into both parts. I get 5x, 2 negatives make a positive 1, and then the negative in the x is a negative x. Okay? And then there's nothing to take in here, so it's just plus x minus 7. Let's collect terms. The x's here go away, so I have 5x, and 1 minus 7, subtracting, give it the sign of the biggest, negative 6. So look at that. 1, 2, 3, 4, 5, 6. Answer 6x. What if these are all multiplication signs? Then, if they were all multiplication signs, it would be x raised to the 6th power. But it's addition. So it is just x to the 6th. Okay? How about this one? Let's collect the x squareds. Would be 9x squared, yes. A negative 5x and a positive 11x. You subtract and give it the sign of the biggest. Plus 6x. How about this one? Here you're going to have to take, and it looks like I don't have everything on the screen for this problem. Let me see if I can fix that up. Okay, that makes it a little bit smaller, but I think we can do that problem, and then I'll put it back to the bigger size. Okay, so we were talking about, we had just done this problem, and now I'm lost. Where were we? I think we were ready to do this one. Okay, so take the negative into both parts is 5x minus 2x minus 6 plus 3x plus 1. 5x minus 2x is 3x, plus 3x is 6x. And negative 6 plus 1, subtract and give it the sign of the biggest, minus 5. There's the answer to that one. Number 8. X cubes, here, here, and here. 3x cubed minus an x cubed is 2x cubed, plus 3 more is 5x cubed. 3x squared, it's the only one. And then minus 3x. Okay, down here, I'm going to have to, this is a lot of work down here. I've got to take the negative in here and here, which gives me 7x minus 5x minus 1. But then there's another negative sign to take in. So this 7 becomes negative, the 5 becomes positive, and the 1 becomes positive. Did you catch that? Now, so I have 6x minus 7x is a negative 1x. Negative 1x plus 5x is 4x. Whoops, forgot the minus 3x. Start all over again. 6x minus 3x is just 3x. 3x minus 7x is a negative 4x. Negative 4x plus 5, subtract and give it the sign of the biggest, is 1x. And the only number that we have here is the plus 1. So it's x plus 1. Okay, and here's the problem I think did not show up very well. So let's do it. We take the negative into all 3 parts here. This thing you can just drop the parentheses. So it becomes a negative 2x, a positive here, and a negative 4. So 3x squared minus 2x squared is 1x squared. 2x plus 5x is 7x. Negative 7 and negative 4 is negative 11. Okay? Let me bring that back up to bigger print. Okay. And that's a little bit better. All right, we've got 2 more to go here. So let's clear this off. Okay. All right, subtract 3x plus 6 from this. So we've got to take 5x minus 11, then we're going to subtract 3x plus 6. Yeah? Follow? Which means you have to take this negative into both parts. Okay? So this becomes a negative 3x and a minus 6. And we still have the 5x minus 11. Collect your terms. 5x minus 3x. 2x. Negative 11 and negative 6. Negative 17. Yep. All right. This one, we're just adding. We're just adding. Okay. 14x and a negative 11x is 3x. And we have a plus 2. 14 and the negative 11, you subtract and give it the sign of the biggest. I just want to make sure I didn't miss anything on that one. Oh, it's negative 11x minus 5. Sorry. It was negative 11x minus 5. So I still have a positive 2 and a minus 5. So it should be 3x, subtract and give the sign of the biggest, minus 3. So today, on your problems, you're going to be doing a lot of work with exponents, and you're also going to be collecting like terms in polynomials. Good luck.